Look up at the night sky. For as long as we've existed, we've wondered, are we alone? This question is woven into our myths, our philosophies, and our dreams. The answer could change everything: our science, our culture, our sense of self. Our sun is just one of hundreds of billions in the Milky Way, and our galaxy is one among trillions. The sheer scale suggests life could exist elsewhere. So we've moved from wondering to searching, building instruments to peer into the darkness. We're explorers now, listening for whispers from distant worlds. For the first time in history, we have the tools to seek a definitive answer. The cosmos is calling, and we're finally learning how to listen. For most of human history, our understanding of planets was limited to those we could see in our own solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These familiar worlds were all we knew, and for centuries we wondered if our solar system was unique. But astronomers long suspected that other stars, scattered across the night sky, might also have their own planets, what we now call exoplanets. The search for these distant worlds transformed a timeless philosophical question, are we alone, into a scientific quest, driven by curiosity and new technology. Exoplanets are incredibly difficult to see directly, hidden in the glare of their parent stars. So astronomers became cosmic detectives searching for subtle clues in the starlight. The transit method, watching for tiny, regular dips in a star's brightness as a planet crosses in front, became a revolutionary breakthrough in exoplanet discovery. NASA's Kepler telescope, launched in 2009, scanned the heavens and found thousands of exoplanets, showing us that planets are not rare, but common throughout the galaxy. In fact, on average, there's at least one planet for every star in the Milky Way, meaning our galaxy alone could hold billions of worlds. Today, TESS, Kepler's successor, is scanning almost the entire sky, searching for planets orbiting the stars closest to Earth, potentially even habitable worlds. These nearby exoplanets are prime candidates for deeper study, offering the best chances to learn about their nature and conditions. With advanced telescopes, we can now measure their size, mass, and even analyze the composition of their atmospheres, searching for signs of life. We've gone from knowing just a handful of planets to discovering thousands, each one a potential new frontier, with its own mysteries and possibilities. The universe suddenly feels a lot less empty, and the search for other worlds has only just begun. Not all planets can host life. Most are barren, inhospitable, or simply too extreme for biology as we know it to take hold. Earth's secret is liquid water. It covers most of our planet's surface, filling oceans, lakes, and rivers, and is essential for every living thing we know. For water to exist, a planet must orbit in the habitable or Goldilocks zone, not too hot, not too cold. This delicate balance allows water to remain liquid, rather than freezing solid or boiling away. The habitable zone's location depends on the star's size and heat. Bigger, hotter stars have wider, more distant zones, while cooler stars keep their habitable regions close in. Finding a planet in this zone is a major milestone in the search for life. It means the planet could, in theory, support liquid water and maybe even life. But water isn't enough. A planet also needs a substantial atmosphere to trap heat and shield from radiation. Without this protective blanket, even a perfect orbit can't guarantee habitability. Some exoplanets, called super-Earths, may be even better suited for life than our own world. Their size and gravity could help them hold on to thick atmospheres for billions of years. Their thicker atmospheres and active geology could help regulate climate, recycling nutrients, and stabilizing temperatures over long time scales. The habitable zone is our best guide, but life might exist in stranger places, methane seas or subsurface oceans, where warmth comes from within the planet itself. For now, we search for Earth-like conditions, rocky planets, right temperature, protective atmospheres, hoping to find a world that feels familiar, yet entirely new. This is the holy grail for planet hunters, driving new discoveries and fueling our curiosity about the universe. Each discovery brings us closer to finding another living world, one that could change our understanding of life itself. Among thousands of exoplanets discovered so far, a select few stand out as especially promising in our search for life beyond Earth. These distant worlds, orbiting stars far from our own, have captured the imagination of scientists and dreamers alike. Kepler 186f, for example, is the first rocky planet found in a star's habitable zone. It orbits a cool red dwarf 500 light-years away, a twilight world where sunlight is dim and red, and the possibility of water exists. Even closer is Proxima Centauri b, just 4.2 light-years from us, orbiting our nearest stellar neighbor. It's the closest potentially habitable exoplanet we know of, making it a tantalizing target for future exploration. Its proximity makes it a compelling target, though red dwarfs like Proxima Centauri can be volatile, emitting powerful flares that may strip away planetary atmospheres and challenge the development of life. The TRAPPIST-1 system, 40 light-years away, is another marvel. It boasts 7 Earth-sized planets, 3 of which orbit in the habitable zone, where conditions might allow liquid water to exist. Imagine standing on one of these worlds and seeing 6 other planets arching across the sky, each a potential home for life, each with its own mysteries. These remarkable systems are natural laboratories for studying Earth-like planets and the conditions that might make them habitable. Thanks to new telescopes and advanced technology, these worlds are no longer just abstract points of light. They're real places we can observe, analyze, and dream about visiting. We don't yet know if they have oceans, clouds, or even life, but their discovery has transformed our search for company in the cosmos and expanded our sense of what's possible. These exoplanets are the first destinations on our interstellar map, guiding us as we take our first steps into the wider galaxy. Finding a habitable exoplanet is just the start. The next challenge, searching for biosignatures, signs of life. Telescopes like the James Webb Space Telescope can analyze starlight passing through exoplanet atmospheres. Each molecule leaves a unique fingerprint. We look for gases like oxygen and methane together, a strong hint of biology. Beyond chemistry, we listen for signals. SETI uses radio telescopes to scan for artificial broadcasts, structured, repeating patterns that nature can't produce. So far, the universe is silent. But we've only searched a tiny fraction of the sky. With better technology, we keep looking for any sign. A chemical imbalance, a strange pulse, a message in a bottle. The search continues, more ambitious than ever. Our galaxy is ancient, with billions of planets and plenty of time for life to arise. So as physicist Enrico Fermi asked, where is everybody? Maybe life is rare, or intelligent civilizations don't last long. This is the great filter theory. Perhaps the leap from simple to complex life is nearly impossible, or advanced societies self-destruct. Or maybe civilizations are out there, but hiding, watching us, or using technology we can't detect. The zoo hypothesis suggests we're being observed with a strict non-interference policy, or perhaps we're simply missing the signals, like ants unaware of a superhighway nearby. The silence could be a warning, or just a sign of our own limitations. The possibilities are as vast as the universe itself. The mystery endures. We stand at a crossroads, equipped to answer one of humanity's oldest questions. The search for life is a journey of self-discovery, uniting us with a cosmic perspective. If we're alone, Earth becomes a treasure beyond measure, a duty to protect. If we find life elsewhere, it will revolutionize our understanding of the universe and our place in it. Either answer is transformative. Every new discovery brings us closer to the truth. We may be the generation to find the answer, or we may pass the torch. The quest itself defines us, born of curiosity and wonder. Are we a lonely miracle, or one of many voices in the cosmic choir? The universe holds the answer, waiting for us to find it.